Hello all. This finds you well. Hope everyone's doing good. I know you have just absolutely missed hearing my voice every day, and so I really thought I would sit and take time and make a video so that you guys wouldn't miss me too much. I really do miss you guys. I have fun in class and enjoy laughing, and I'm sure you guys are tired of this craziness and not being able to go anywhere or do what you're used to. So know that I'm there with you, and if you need anything, don't hesitate to give me a holler. I am going to go through, and I'm essentially going to combine two here. I meant to have one out for you guys yesterday, and getting everything situated so that we could have a semi-normal day of class from home is significantly more difficult than I was anticipating. So I'm going to try to catch up with today's and going to kind of mix the two together. Remember, ballpark, you're aiming for about 18 problems a day. That's a rough estimate. If you do 18 problems a day every day, including yesterday, you will get finished by the time it's due. Feel free to work ahead if you want, but don't try to knock it out in a day or two. Mainly just because that won't do you nearly as much good as having a little bit every day. Our goal is to keep us fresh on this. Since Governor Cooper has declared we will be out until at least May 15th, we are going to have to cover some new material. We will start that after all of this. May will introduce, because I know some of you like to work ahead, I may introduce some of you to be able to look at that before then, just seeing how things go. But obviously it won't be required until after this is done. Goal due date on this is April 3rd. Please do not wait till the end, really, in all seriousness. Try to schedule just a little bit of time every day to hit some math, just so that your math brain doesn't, turn to jelly and leak out your ears. That's our goal. So anyway, I'll quit yammering. Hopefully you've been reading all of my posts in Google Classroom. They're extremely well written and highly entertaining. So I can understand that you could hardly, keep yourself from reading them. But just in case you hadn't, that was a brief overview. Going to do super quick reminders here on what's going on with trig, and we'll get started. So a quick review of your trig ratios. These guys up here, we got sine of theta equals opposite over hypotenuse, the cosine of theta equals adjacent over hypotenuse, and the tangent of theta equals opposite over adjacent. And you remember we had the some old hippie called another hippie tripping on apples. We'll go with apples. And that's just to help you remember the sine opposite over hypotenuse. Some old hippie called cosine adjacent hypotenuse, called another hippie tangent opposite adjacent tripping on apples. And that just helps you those ratios, because you're always going to use those ratios when you're setting up your triangles. And it doesn't matter whether you're finding sides or, like you are on this worksheet, that you are finding angles. And remember, when you're using angles, you have to use your inverse ratios, which are exactly the same, except instead of the angle measurement going inside the parentheses, you're going to wind up putting your side ratio in the parentheses. So for example, your inverse sine would look something along like this when you put it in your calculator, and that's going to give you theta degrees. Remember that your calculator needs to be in degree mode. If you have forgotten how to get there, that is up there beside your delete key, up there beside the second, there is your mode. And from mode, you go in there and you scroll down till you see there's radian or degree, and you're going to select degree. Do remember, anytime you're doing trig stuff, it needs to be set like that. So do be careful with that. Desmos does do trig as well. If you're one of my people that you're trying to do this at home without a calculator, there are some graphing calculator apps for phones. Feel free to dig one of those up and use that. But Desmos is a free one if you're online that you can use. So don't forget about Desmos. It does all that stuff. All right, so let's set one of these up looking for sides. So if we look at number 1 here, one of the best things to do first, if you remember, I said doesn't take but a second and saves you a lot of hassle, is to label your sides. That way you know what ratios you're dealing with. Keep in mind the easiest one to find first is your hypotenuse. You can draw a line through your right angle and it always cuts your hypotenuse. So we're going to have that one there. hypotenuse is this side. Then you got to look at your reference angle for your other two. So reference angle is right there. Adjacent's the one touching that. That's going to be 47. So that's your adjacent side, which makes your opposite 20. Also said one way to remember it, if you have trouble, just like we did with the hypotenuse, you can cut your reference angle, draw a line through that, and it'll cut through the opposite side, and it always does that. So the two that we have labeled here are opposite and adjacent. If we look up here at our ratios, opposite and adjacent is tangent. So when we go to plug that in our calculator, since we're finding an angle here, we're going to use the inverse tangent of opposite, which is 20, over adjacent, which is 47. Helps if I write the correct number there. There we go. 47 is going to equal my angle measurement. And if I remember correctly, it says to do this to the nearest degree. So what I'm going to do is I'm going to go to my calculator. I'm going to type in the inverse tangent, put in my parentheses, 20 divided by 47. And what's going to happen is I'm going to get 23.0513 is what I've got on mine. So nearest degree would be 23 degrees. Okay, let's look at another one. So looking at number 2 here, just taking a quick second, labeling my hypotenuse, which is easy to draw through the right angle there. So this is going to be my hypotenuse. Reference angle, be able to draw through that. That side over there is going to be my opposite. My adjacent's the one that's touching it. Doesn't take but a second to label those, and it really does make things much easier. Now, if you look at which one of those labels has numbers with it, that would be my adjacent and my hypotenuse. Adjacent and hypotenuse means we're in the cosine range here. So we're going to use that. We're going to go over here and we're going to say cosine, and we're going to use the inverse because we're looking for an angle of that ratio. So adjacent over hypotenuse. The adjacent is 48 over the hypotenuse, which is 50, equals my theta degrees there. So my missing angle measurement is going to be, let's type that in our calculator, 43.8309, etc. So nearest whole degree is going to be 44 because we had 43.8, so 44 degrees. And that's that. Do remember, when you can, try to remember to use your wavy equal sign, meaning approximately. If you'll notice, even I forgot it. I understand that happens. So if you can try to remember to put that in, that is a good habit to be in. And mainly that's a good habit to be in just because we're not using exact measurements right now. So that really is something that's useful to go through that and have that, especially as you're working through longer problems. But obviously sometimes you forget. So if you can just keep in your mind what you had for exact and not exact, won't be the end of the world. But that's a great habit to get into if you can. Let's look at one more here. Looking at one more here. Going over number 3. So if we look at it, again, taking a quick second to label our sides, quick draw a line through, that gets us our hypotenuse on that side. We can do a quick line through that way, shows us our opposite, and then adjacent is the leftover side. And again, taking a quick way to reference those really is helpful, especially as they flip the triangle around on us all over the place. But if you notice, sides that we have with numbers are our opposite and hypotenuse there. So those are the ones we're going to deal with over here. Opposite and hypotenuse is sine. We're going to be using that to put our ratios in. So we got inverse sine of opposite, which is 14, over hypotenuse, which is 48, equals theta. That's our missing angle. Now all we're going to do is type that in our calculator. When I type that in the calculator, I get 16.26. So going to the nearest whole degree, that would be approximately 16 degrees. And that's it. So you're finding angles pretty darn easy, super duper simple. All you got to do is plug everything, you set everything up right and plug it in your calculator. So that's pretty much this whole section here. Going through those probably won't take you that long. And that's the goal. I didn't want you to spend tons of time doing this every day, but just enough to try to keep it fresh in your brain so we didn't lose everything. Let's look at another example here, and I'll try to keep things moving along so this video doesn't get too terribly long. So over here now we're finding sides and just drawing attention that we are rounding to the nearest tenth now. Similar setups while we're doing this. We're still using our ratios over here to the side, the sine, cosine, tangent, and we are solving for a side. So what we're going to do, we're going to slide in on one of these problems here and get started. All right, so this first one here, again, it doesn't take but a second to label your sides. If I go there, that's my hypotenuse, drawing through that right angle. If I go through my reference angle, there's my opposite, and then that makes this my adjacent. Now, you may be able to recognize those without drawing the lines, but like I said, especially as they flip the triangles around, sometimes it makes it a little easier to have that reference there. If you look, the ones I've got numbers with, I've got an X with the hypotenuse, I've got a 19 with the adjacent, so I'm going to be using hypotenuse and adjacent, which makes this a cosine problem. So I'm going to set that up, and this one's going to be cosine of my reference angle, which is 62 degrees, equals adjacent, which is 19 over my hypotenuse, which is X. This, if you'll remember, I got to solve, and I treat my cosine of 62 just like it was a variable or a number. It's all going to stay together. It's one term. So what I've got to do is I've got to get rid of that X. It's on the bottom, and if you recall, I said it's like a boat with an anchor. I got to get rid of the anchor before I can move the boat. So I'm going to multiply by X, multiply by X. That cancels those out. I get X times the cosine of 62 degrees equals 19. Then we're going to divide by the cosine of 62 degrees. And that means that cancels out, so I'm left with X equals 19 divided by the cosine of 62 degrees. Now, if you're able to process that, if your brain will let you recognize that anytime X is on the bottom, that your cosine ratio and the X are going to trade places. That's a bit of a shortcut, so you can make your way through that if your brain will allow you to recognize that. If you need to do the work to get it right, that's fine too. This right here is what you're going to type in your calculator. We're going to go and we're going to type in 19 divided by the cosine of 62. Reminder that you're supposed to be in degree mode while you're doing this. So as you type that in, make sure that you've checked and make sure to check that you're in degree mode when you go to do that, so that when you type that in, you get the correct answer instead of, who knows what you're going to get. So I type that in my calculator. I get 14.471 rounding to the nearest tenth. That means if I've got 40.471, I'm going to look at that 7 to judge my 4. That's 5 or more to raise the score there. So my final answer is going to be 40.5. Final answer on that. Okay? Let's do another one. All right, so take a second to label these. I've got that. There's my hypotenuse. Hypotenuse, draw through my reference angle. There's my opposite side. That makes this my adjacent. I look and see which ones I've got labels for. So I've got a label with the adjacent there of 12 and a label with the opposite, which is X. So adjacent and opposite, that's going to be my tangent ratio over here. So I'm going to take that, set that up. That's going to be tangent of my reference angle, which is 64 degrees, equals my opposite, which is X, over my adjacent, which is 12. And now I'm going to solve. So this time the 12 is on the bottom. The 12 is my anchor. So I got to multiply by 12. Multiply by 12. And this time when I do that, 12 on the tangent, I don't need that set of parentheses, tangent of 64 degrees equals X. X is already by itself. So all I've got to do is go over and type that into my calculator, making sure that I multiply that by 12, get the whole thing in there. So it's going to be 12 times the tangent of 64. I type that in my calculator and I get 24.603. So 24.603. Again, looking at that 0 to determine whether or not I round up or down, so it's going to stay the same. So my final answer would be 24.6. Final answer on there. So same kind of thing as when you were doing sides. I went through one of all the ratios on the sides. I can do more, with the angles. I did 2 of the ones with the sides. I can do more if you need me to. Like I said, I'm not trying to make this video too incredibly long here. I know it gets hard to pay attention when they ramble on for too long. If you do need help, please don't hesitate to email me. I'm available during school hours pretty much instantaneously. I've been within just a minute or two or three for most replies here. Sometimes faster than that, just depending on if I'm helping somebody else or not. But outside school hours, feel free to email me as well. It just may take me a little bit longer to get back to you. Well, I hope y'all are all doing good, and I'll have another one of these guys for you tomorrow going through some more stuff. Take care.